I got the pressure gauge face back off Bob. As you can see, he's made a wonderful job of restoring it. When you think the condition it was in, the clock's mounted behind it now, a little electric clock, and it's going to look really nice on the wall in our kitchen. Originally there was a stove come out of here with threads on. Now I don't want to damage the internals of the clock. I want two people to say I've destroyed it. I haven't destroyed it. I've done no damage at all to the clock, and I won't be doing any damage to the clock. In fact, I'm actually saving it from being destroyed. So what I'm going to do, I've got a little bronze pipe fit in here. I've had it in the fire to warm it up and loosen things off. I'm going to take that nut off and adapt that bit of threaded brass there just to come out the bottom so it still looks like a pressure gauge. My friend Nick's cutting the glass for it, so hopefully we'll have it on the wall next week. Just a simple electric clock on the back. The hole in there hasn't even been enlarged, so nothing at all has been damaged on the clock. This is the works out of it, the board and tube, so that was in there like that. Be easy to cut that off and leave that in, but it would destroy it, and I just don't want to do that. So I'm going to use that instead. This is a new steam fitting I got at I think it come from a car book sale. That nut's been on there for a long time. See, I couldn't move it at all, and I actually put it in the wood burning stove that was dying down, and that's released whatever joint and compound was on there. Should have enough there to part that off. Bronze up the brass. Tell by the way it's machining. So that will be polished up, the check nut on either side, screwed into there, and that's going to look the part. Looking forward to getting this polished up and up on the wall. As part of my normal day job, I replace loads of these. These are car wheel bearings. These are an example of the most popular sizes. When you're replacing the wheel bearing, what you must do is press the bearing into its housing on that outer face there. If you press on the centre, you'll damage the bearing. So what I need to do, or what I'm going to do, and I've been going to do this for years actually, is machine half these bearings down. Not much, probably 10-15 thou off there, which means I can use that to push in the new bearing. So that'll be slightly smaller than the new bearing, and that'll push the bearing in without damaging it. It's an opportunity to do a little bit of setup work on the 4-jaw chuck using a clock gauge, and also a chance to machine some really hard steel, because believe me, these are really hard, glass hard, file won't mark it, just skid straight off. If the bearing is marked by a file, it means it's a cheap bearing. We all know all about them. So we'll set these up in the 4-jaw chuck, get them running nice and true, and play around with different speeds and feeds and see what sort of job we can do in machining them down. You notice on the 4-jaw chuck there's rings, series of rings all the way around there for decoration to make it look pretty. That uses a reference point for each jaw. You can wind each jaw and turn it in line. See that part of the jaw, that part there, that part there, and you know that all 4 jaws are at roughly the same place. That's obviously far too slack, so we'll bring them all in, one full turn. Somewhere near. Full turn on that one. Full turn on that one. Half a turn should grip it. Right, so it's got a hole of it. You can see it's running out. It's not running out a mile, but it is running out. What we need to do is clock it in on this face here and that face there. In this particular application, that face there is the one we need running really true. I'll bring the clock gauge in, and so far it actually is. It's not a million mile away, but it's not right. The gauge I normally use, I've actually dropped down the back of the lathe, and I haven't actually ventured in there to get it yet. I'll use this one, which has actually got a much bigger scale on, and it could well be better for video work because it'll be easier to see. Right, hopefully you can see that there, and it's got 50 thou run out. What we'll do is find the highest point, which is there, which means that jaw needs tightening. The part's going to go across that way. So our 50 thou, we'll loosen off that one, tighten up that one. That's made it twice as bad. John, man. Right. Once again, we'll find the high one, which is there. We'll tighten that up. Right, high one, which is there. You need to be careful because of high one again, that one. So if we loosen that, tighten that one. Now we're getting somewhere now. High point, which is that one. It's actually giving a strange reading there because it's not. Right, want the high one again, which is that one. I'm just going to clean this. Right, high point, which is there. If we loosen this one up very slightly. Right, it's getting very near now. That's pretty good actually. High point, which is that one. Right, that's good. put a clock on the outer face just to make sure. Find the high point again, which is there. Right, that's good. Right, you can see it's running nice and true. Touch it off. I'm going to dial in 0.2 of a mil cut. I suppose it'll take 0.4 off, which is plenty clearance. Just feed it in by hand. It doesn't really like that very much. Try a different tool with a different tip. That's cutting a lot better. As you can see, it really is hard material. I'll try running it faster. Right, that's obviously not the way to go. Try slowing things down. Tip's still good. That's enough to do the job, enough material removed to do the job anyway. Just going to turn the tip round and damage the corner there. Right, we'll try it again on a nice slow speed with a new tip. That's 0.1 of a mil, and it's taking off quite nicely. No sparks, no drama. It's actually machine it off instead of just rubbing it up. It's not the best finish in the world, but it'll certainly do for what I need to do. I'll do one more. This one's obviously bigger. Bring each one out a full turn. So I'm laying each end of each jaw onto the end of the chuck. That's nearly in. Right. Then we'll put the clock gauge on again, dial this one in. I'll put it the other way around, because you can actually press on that part there just to put the right, same again, you find the high point, which is this one, so it wants to go across that way quite a bit actually. High point again, which is that one. Right, so we can see that better now. Right, that's not bad. So learn from the last one that the feed needs to be nice and slow. Seriously hard material that. That's probably the wrong grade tip for machining steel like this, I don't know. It's basically just a tip I've been given. I know it works quite well on ordinary grades of steel, but like I say, this is really hard. But there's enough off there, so that'll be there's enough being machined off there, so that'll be a slack fit in the bearing housing, so it will push the bearing in. You can see that inside the bearing, the damage there where the track's all badly pitted.